everyone. I'm Flavian. I'm an open source engineer here at Prisma. I work in the Prisma Labs team remotely from France, and I work with a colleague of mine named Jason Kurt, who works from Canada, and we have some exciting stuff to show you. So we are going to talk about backend development, and I'd like to start by trying to highlight the challenges that you might have as while you develop a backend. So some of the challenges are that your applications needs to be scalable, and by that I mean that it needs to have great performance, it needs to continue to evolve in the long time, it needs to be secure, it needs to have great error handling, and last but not least, and we'll talk about it a long time later during the talk, it needs to be type safe. So all of that is already possible with a lot of technologies, but it's often at the cost of productivity. And what helps developers be productive? Well, frameworks. So before going into any details, I'd like to jump into a demo straight and kind of show you what we've been working on. All right. So I'm going to run a command here, npx future create. Future is our code name right now for whatever this is going to be named in the future, so please don't be confused by that. This command is going to initialize the project, it's going to install the dependencies, it's going to seed the database and run the GraphQL server. This is going to take a while, so I've set that up already for you so that we don't lose too much time. So before going into the code, let's jump straight to the playground. We actually have already here, and let's see what the schema looks like. So we have a very simple GraphQL schema. It has a type user, it has some ID, some name, and we have a simple query. We have some pagination by default, and we have, well, it returns a user. So let's try that query. User, ID, and name. OK, so we have a single user. Let's jump to our DB UI, whatever it is. Let's create another one. Nicholas, and obviously don't do that in production, but let's fake a super secure SSH password. Let's run the query again, and we have our second user. Now let's try to come up with the most simple blog example we can do as fast as possible. So let's first jump into our database schema. So here we can see that we have a model user. It has a name, it has an ID, some ID name, and some password. And then we can jump as well into the code. So let's see how we actually create the GraphQL API. So we import here app from the future, whatever it is. What we do here is we expose an object type. It's called user. And we project some field from our database to our GraphQL API. So we take some field from the database, and we expose it in our GraphQL API. And you can notice here that we actually don't expose the passwords field. And I'd like to go back to some slide first, just to make it clear. This is the traditional three-tier architecture that you might have in an application. And you have three separate layers: the data layer, the API layer, and the front-end layer. And what I need to make sure that you understand is that what you have in your database might be very different than what you have in your API layer. And so because of that, while it might seem redundant to repeat ID, name, and same for the schema, while we already have the information, in the most simple cases, yes, you will probably have a one-to-one mapping, but in a lot of cases, you will actually have a lot of information that you might not want to expose. So let's move on. And we have here, as we said, like we don't expose the passwords field, and then we have a query type where we expose the generated query to read some users. Yes?
So when you type the create command, did that actually bootstrap this?
Exactly, yes.
This is an example schema as a starting point.
Exactly, yeah. Cool. Is it clear for everyone so far? I'm trying to go fast to make the demo as fast as possible. All right, so let's try to evolve our schema here and come up with our very simple blog example. So we're gonna need some post. So let's create the post model. It has some title. It has some content. A post has an author. And it has, I guess, some comments. Now let's create the comment model. So comment has, well, a content and an author. Ugh. OK, so what it's going to do in the background is migrate our local database and update our framework here to enable us to project these fields into our API. So we can start by now adding some of the types that we want to expose in our GraphQL API. T.model.id. So there we go, T.model.title, T.model.author. Let's also create the comment type. ID, content, and author. Now we need to expose the post on the user. And notice how all these fields are, like, this is entirely type safe. Every field that I see here comes from my database schema. If I rename one, this will change and this will break, but we'll talk about that later. So let's expose the post, and then let's maybe add a query field here to find all the posts. And that's pretty much it. I can now go to my playground again. I can see here that automatically I can now query for the post. Title, there is no data. I could scaffold some, but there is no need for now. So we now have, like, very quickly, there's no authorization or whatever, but we bootstrap very quickly a super simple blog application. So now that I've showed you a bit what we've done, I'd like to deep dive a bit into some of the subject that we think is very important for a backend to help you be productive as a developer. And the first subject will be end-to-end type safety. So it's a fairly complex subject, and to make sure that you get it right, I want to go back to the very root of your application. So let's assume you have a database. And if you have a database, it means you have a database schema. And if you have a database schema, what we can do with that is do some code generation to generate an ORM that will make sure that whatever query you create will be in sync with the schema of your database so that you cannot send stupid queries. And this, by the way, I'm using the word ORM here. Please don't think about a fully fledged ORM. This is just for convenience. What we use under the hood is just a query builder. And if you think about it, this is some of the value proposition of Prisma, if you know it. So that layer here, we can call it the data layer. This is one part of your application, and it refers to the three-tier architecture that I was talking about before. Then let's assume you have a GraphQL API. And if you have a GraphQL API, it means you also have a GraphQL schema. And what you can do with your GraphQL schema is make sure that your GraphQL API is type safe. So we'll use the schema that you generate as you type to generate some TypeScript types to make sure that your resolvers are typed, that you can refer to types in other parts of your GraphQL schema in a type safe way. And this is the API layer. And then finally, we won't cover it, but there is a front-end layer, and it's still important to be here to really understand the concept of end-to-end type safety. And so what's important with end-to-end type safety is a couple of things. First, that every layer are type safe, and we can see here that the data layer in itself is type safe, the API layer in itself is type safe, and then the front-end layer, whatever technology you use, let's assume it is. But what's really important then is that across layers, you also have type safety, because eventually the API layer is going to communicate with the data layer. And the front-end layer is also going to communicate with the API layer. And so if independently they are all type safe, but while communicating they are no longer type safe, then what can happen is that, again, like the API layer can send stupid queries to the data layer, and same for the front-end. The front-end layer might send stupid queries to your GraphQL API. But again, thanks to the schemas, these are the interfaces that make sure that one layer can talk to the other in a safely manner. And so we can again rely on type generation to make sure that your API layer can never send anything stupid to the data layer, and the front-end layer can never send anything stupid to the API layer. And to simplify a bit all of that, if you think about it, so this is a typical application. You have a database, you have an ORM, you have an API, and you have a front-end. Once everything has interfaces that are loaded down, whenever you're going to change something on the leftmost part of your application, so the database, let's say you migrate a field, for example. When you're going to migrate the field, what it's going to do is change the schema. So it's going to regenerate the ORM. So if anywhere with your ORM you are using that field, it's going to break. And because your API is using that ORM, your API is going to break too. And because the front end has a schema, and maybe you're going to change the schema of your API as well, the front end will break too. And suddenly your whole stack is completely locked down. And by the way, when I mean it's going to break, I mean at compile time. Because what you want is you want something to break, but before it actually goes to production. And so before even doing anything, just by migrating your database, suddenly you'll make sure that you won't have any runtime errors throughout your whole stack. So this is what we call end-to-end type safety. And I'd like to give you a quick demo back to the small demo that I had before. So it's going to be very simple. What I'm going to do as explained, so obviously we don't have the front-end part, but it doesn't really matter. I can, for example, say, oh, actually, later on in my development application, name should be name, full name. So I'm going to rename that field. And we'll jump back to our code. And suddenly, what we'll see is that that function breaks. I can no longer project the name field from my database to my GraphQL API because I've renamed it. And so this makes sure that I will never be able to expose such a name. So what I need to do if I still want to keep the name field and project it to my database field is to call it full name and then maybe alias it. So now I've made sure that I've migrated my database. I still project that field to my database, but I don't break the front end. If I kept it as full name, then what would have happened is that my GraphQL schema would have changed. And we can see that here, my GraphQL schema would have changed. My front end would have consumed that schema, and it would have rated too. So that's for end-to-end type safety. Let's jump to the next topic. Zero config and conventions. When you are a framework, something that is very important, I think, is that you rely on conventions. And why conventions are super helpful is because it dictates how your code should be structured. And if you are a great framework, what you can do is lead users to the pit of success. If the architecture that you force your users to is something scalable by default, you make sure that they never can fail. It also reduces the margin of error. People cannot fall into some stupid problems. And it also reduces the cognitive load. You no longer have to think about how you structure your code. You just follow what the framework tells you to do. And last but not least, because we have some conventions, the framework can make assumptions about your whole app. It knows where your file is because maybe you need to have a GraphQL file. We know where it is, and that enables some workflows that we can do about it, such as scaffolding code, for example. We can make sure that whenever you migrate some database and you create a new type, we can scaffold for you the equivalent of GraphQL for you to expose these fields. Last but not least, error handling. So type safety is important to make sure that it doesn't break at compile time. But still, sometimes, and more often than not, the errors that are raised by the type system are super cryptic. It doesn't really help you understand what's going on unless you know really what you're doing. And so what we need is human-readable error messages. We need very detailed error message. And the reason why we can provide such detailed error messages is because if you think about it, if each individual component of an application raises errors about themselves, about only their self-awareness, they cannot like the only thing they can actually is like, yeah, provide error messages about themselves. But once you are a framework and you couple a lot of components, you suddenly have a vision of the whole stack. You know how each of them interacts, and you can provide error messages that gives very efficient, well, very useful, error messages across the whole stack. So you can make sure that, for example, if you expose a GraphQL field that does not belong to your database, that you tell explicitly people what's going on. And last but not least, we can provide meaningful stat traces. So let's go and give a demo of that. This was the one. Yep. So let's migrate the database again and say, actually, it's not full name, it's first name. So we'll migrate the database again. And once it has regenerated everything, we'll get a meaningful error. So what it tells us here is that we have a GraphQL user object type that is attempting to expose a field from the model in your database that is called full name. Unfortunately, our database schema does not have such a field. So now we see that we have an error that goes beyond just either GraphQL or the database. We have linked the two, and we can provide our messages like that. Not only can we do that, but we can also provide suggestions. We can say, hey, like, did you mean maybe first name? Because I know what's in your database, and I know what's in your GraphQL API. So, yep, let's go ahead and fix it. That's it. We also have a nice stat traces. It tells us where it is, and we can jump to the error. Let's move on. So some of the key features of the product that we're building are, first of all, end-to-end type safety. We think it's very important, and nowadays it's becoming a default for every developer, especially for big companies to scale. We want something that has almost, well, zero config. If you've seen the demo, there is no config at all. You just import app and everything works by default. And this is thanks to the conventions that we create for you. I haven't talked about it, but deployment should also be something that is part of the story of that framework. We want things to be very easily deployable. And again, this is only possible if you're a framework and that you know every components. So we can make it, for example, very easy for you to deploy to Heroku, to Netlify, to Now. There is no boilerplate. I talked to you before about the workflows and about scaffolding. Again, like I showed you an error where like it says, did you mean something? Maybe we could go one step further and actually auto-fit that error for you. And last but not least, having these conventions allows for plugins. And when you have something standardized, it allows for an ecosystem as large as Rails or Django or whatever, because everything has the same interface with which it can communicate. So suddenly, everyone is not doing something in his like area. Everything is dedicated to one framework, and the efforts are joined towards a single rule. As Nicolas said, we are hiring. If you want to be hired, check out prisma.io/jobs, and thank you very much. Is there any questions? Yep, please.
Yeah, well, thanks a lot for the presentation. Really clean, really
Thank
clear.
you.
And the code, the live demo actually worked, which is I've been to a lot of I'll say that's a 10% rate that live demo works. Anyway, first question would be, can you use the models that you just declared to actually, because the problem we always have it when we try to do end-to-end testing in the backend, we have to mock always a database, and kind of the standard way that I've been doing was to do the mock database in some Docker container, spin it up. Could you use these models to actually mock like a whole?
Yes.
Is that something?
So I haven't really talked about the technology under the hood. there is 3 technology. One of them obviously is Prisma, and then there is Nexus and nexus-prisma. The important one here is Prisma. There is a tool that is in the process of being created. It's actually already public, but we stopped working on it. It was called the Prisma Test Utils, and the whole idea of that tool was to generate a full database, to seed an entire database based on your schema. And so what you could do is, with Jest, every test is run not sequentially, but asynchronously on the same file. So you can spawn a pool of database on a single file. For each of them, seed automatically and deterministically the database based on your model, and then run some tests against it. And I think this is precisely what the kind of thing that the framework could completely abstract, because then again, like, we know where your schema is, etc., and we can automate all of that for you. Something else that we've been thinking about is GraphQL code generator, and there are others, propose the ability to generate for you a GraphQL client based on your schema. And so if you want to do integration tests, you'll need the database, but you'll also need, if you really want integration tests, what you want is just to run queries against your GraphQL API. And so we could have, on one hand, completely hide the fact that we generate databases under the hood and just let you run queries against your GraphQL API. And you might want to do okay, I just want to check whether when I create a user and it already exists with that email, it fails, and that's it, boom. And on every test, it would flush the DB and start the game fresh in another test.
Wow, that sounds too good to be true.
Cool.
And the second question, I'm being a bit selfish here. This is really, it looks like it's super easy to bootstrap a project from start, but we usually work on projects that are already there. We already have a REST API. We are using TypeScript. How would you go about introducing this to a project that's already running?
It's an interesting question. So there's, I think, 2 answers to 2 points to your question. The first one is Prisma as a data layer. I watched the both while saying that word. Prisma as a data layer supports, I think it's not entirely stable yet, but it supports introspection. So what it can do is generate that schema for you based on an existing database. And then what we can do is, once we have that schema, we can actually scaffold for you all of that, right? This is easy. This is just reading your schema and doing a one-to-one mapping with what you expose. And then from that, you just remove what you don't want or you evolve. So given a full database, we could potentially just take this, so introspect your database and then scaffold for you a completely working GraphQL API that just exposes your full DB. And then you start from that. Make sense? Are there any other questions?
Are you using any plugins with VS Code? It's so well aligned.
Yeah, this is this is the Prisma plug formatter basically that we have in VS Code to automatically format the schema.
The best part. It's like magic.
Okay, cool. Thank you then.